Good morning, or afternoon, or evening, or whatever time you're working on this. This is the first of very many videos that you will find for working on the New York State Regents exams in Algebra 2 and Trigonometry. I'm going to put this little disclaimer on the front of every video. If you are here just to copy the answers down and put them on a piece of paper to turn in for some grade, you are fooling yourself. The Algebra 2 Trig Regents is not an easy Regents by any stretch of the imagination, but it clearly is a doable exam unless you decide that all you're going to do is copy your friend's work or copy what you see here, and that is a waste of your time. You need to actually try the problems before you come here. If you have a blank piece of paper in front of you and all you're doing is looking for my solutions, again, you're wasting your time. Take the time, do the problems, see how you do, and then come see me. Or do most of them, and then, if you don't have a clue how to do a problem, then come use these videos in order to help you. They're here to assist you, not to help you cheat. Alright, kids. Enough of the daddy lecture. First exam that we're going to be doing today is the New York State Regents exam. This is January 2015. In order to keep the upload times kind of small, I've decided I'm going to do them in small video chunks. This one will be the first 14 questions. There's 27 multiple choice, so this will be the first 14 questions. You'll see me look down on my notes just to make sure that I have not made a dumb mistake. Anybody that's shooting for 100 on this Regents exam, I will tell you one thing. You'll probably make a dumb mistake. Somewhere along the line, you'll make a dumb mistake. If you can find 1 or 2 or 3 different ways to solve your problems, generally, you'll get the right answer. If you think you're stuck with just one way to solve a problem, sometimes that's a problem. So one of the things I'm going to be doing during these videos is trying to show you multiple ways to solve problems. Sometimes it's just problem solving. You just got to chug and chug and chug. But sometimes you can do it graphically. Sometimes you can do it algebraically. Sometimes you can do it in reverse order. Lots of different ways. All right, without further ado, let's get going. June 2010, algebra. Why do I only have one page here? Page 2. I wonder if this is not going to let me go back and forth between pages. That's going to be very upsetting. Alright, we are looking for the common difference in this arithmetic sequence. An arithmetic sequence is a sequence where you're adding and subtracting to get from one term to the next. So if I look at these terms and I say, oh, from 5 to 8, I added 3. From 8 to 11, I added 3. From 11 to 14, I added 3. Can't get much easier than that, chillin'. Alright. What's the number of degrees in an angle whose radian measure is 11 pi over 12? Little disclaimer, little fun for you, a little fun fact. Pi is 180 degrees. You can think about pi being 180 degrees. Therefore, this is 11 over 12. That's slightly less than 180 degrees. So, clearly, these choices make no sense. We'll get rid of those right away. Don't choose dumb answers. Now, we're really close to pi. So if I had to guess and I had no idea how to do it, I think I would guess this 165. I'm not exactly sure. So what we will do is we'll take 11 pi over 12. Now, in order to convert from radians to degrees, your conversion is to multiply by 180 over pi. Now this comes up almost every single exam. Sometimes they give you radian measure like this. Sorry about the way my pen's working. Hopefully it'll get better. Sometimes they give it to you just as a number, but you still have to multiply by 180 over pi. Alright, so I can do this with my calculator, but this one's too easy. These cancel. These cancel. 12 goes into 180. Well, let me show you how you do it in your calculator, because some of you are like stressed out. So let's come over here, and I will be using the Inspire. It's a great calculator. I'll do control division just to make sure I don't get this wrong. 11 divided by, oops, I'm going to put over 12. Now notice I'm not putting in the pi. There's no reason for it. Times 180. And you'll find out this is 165 degrees. Okay, so there's our answer. 165 degrees. That's it. That's all she wrote. That's how you do it. Man, I'm going to have to switch every page. All right. Children. Negative exponents have absolutely nothing to do with being negative. If you're giving something like x to the negative 2, that's equal to 1 over x squared. Notice this thing just comes to the denominator and becomes positive. X to the negative 4 equals 1 over x to the positive 4. Gotta love these ones. These ones they put on here all the time. X to the negative 1/3. Well, that's just 1 over x to the positive 1/3. So, if I'm dealing with a problem that's already a fraction, what I like to say to kids is you have a to the negative 2 on top and b, in this case, b to the negative 3 on the bottom. If they're on the top and they're negative, they come to the bottom. Well, then, if they're on the bottom and they're negative, they come to the top. So really what this becomes is b cubed over a squared. Now I'm going to go use this information that I have. A squared's easy, that's just 9. But it's this negative 2 cubed. Well, remember, when you're dealing with negatives and your powers, odd exponents will give you a negative. Even ones will give you a positive all the time. So negative 2 times negative 2 times negative 2 is negative 8. They should have put negative 6 in there because I bet some of you would have bid on that. And the answer is negative 8 over 9. All right, we're moving on to page 2, and I'll have to set it up for... what are you doing? That's going to be annoying to have to do that every time. Anyway, it doesn't matter. Okay. So which graph represents this function? 0, 1, 1, 2, 2, 4, 3, 8. Clearly it's not a linear function because the differences in the y's are changing. You know, at first you have a y value of 1, and then you have a y value of 2. That's only a difference of 1, but then it doubles and then doubles. And if I look at those y values, I'm looking at doubling. So the y values are doubling while the x values are just going up. And maybe what this will require is a quick sketch. 0, 1, 1, 2, 2, 4, 3, 8 every time you're doubling. And clearly that is an exponential function. And we're looking for an exponential function there. And I will do this. Now, remember what I said? It's great to be able to know for sure if you're right. Well, let's know for sure. Let's know 100%. I think I closed my calculator. Why would I have closed my calculator? That would have been dumb. Sorry, kids. That's going to take a couple seconds to boot up. But I want to know for sure. It's TI Inspire student software, even though I'm a teacher. And while I'm doing this, I'll take this time to say, oh, I'm a Brugger's cup of coffee. I'm going to drink a lot of coffee during these videos. You'll get used to it. Oh, I just spilled coffee on myself. And I'm like, I think my cup's leaking. Either that or my mouth is leaking. So, we'll go to the home screen. We'll click on graphing. And I want to graph 2 raised to the x. That exponential 2 raised to the x. There it is. Not very useful. I want to go look at the table. To get to the table, we just hit Control T. That's the easiest way to get to the table. And look at that. 1, 2, 2, 4, 3, 8, 4, 16. Is that what I have over here? Where am I going? Oh, 3, 8. Well, that was the last one. Yes, clearly that's the answer. All right, so which set lists all of the real solutions of this function? Real solutions are roots or zeros. Remember that. Their roots or zeros. So this is a really simple question. We're looking for the roots or the zeros. There's the zeros. They're at negative 2, 0, and looks like positive 3. So negative 2, 0, and positive 3. Choice 4. Alright, moving on, kids. We're almost done with this one. Oops. Why is it doing that for me? What problem do I want? I want 6. I'm on the wrong thing. All right, let's, come on, click. That's not fun. All right. Ooh, simplifying radicals. First and foremost, you see the negative. The square root of -1, or the square root of anything that's negative, will always yield an I. So if the answer doesn't have an I in it, get rid of it. They weren't very nice to us. So what we will do is 300 is amazingly easy. It's really -100 times 3. You're looking for a perfect square. In this case, it's 100. They were nice to us. The square root of -100 is 10I. There's our answer, kids. All she wrote. Moving down. 20 different cameras will be assigned to several boxes. 3 cameras will be randomly selected and assigned to box A. Which expression can be used to calculate the number of ways that 3 cameras can be assigned to box A? You need to determine whether or not the order of how things were selected, or put, in this case, put in the box, matters. If it matters that you put the pink one first and the red one first and the green, or matters what order you come in for some reason, then if the order matters, you're going to be using permutations. P, N, P, R. If the order, this is when order matters. When order doesn't matter, you're going to be choosing NCR. Well, in this case, who cares how you put the cameras in that box? The cameras are just getting put in that box in some random order. So we need to use C. Now, what the numbers represent is, and I'm messing with my coffee, sorry about that. What the numbers represent, the 20 represents how many you have to start with, and the 3 represents how many you're actually selecting. By the end of this show, I should be drenched in coffee. So, I hope not. That will look weird. So what we're going to do is we're going to just pick this one. We want it, the order does not matter. Pick them in any order you want. It's just what kind of, and the other thing is, this one you'll almost always use with groups or committees or teams. This one usually is about races or places, you know, first place, second place, things like that. All right. Factor completely. Factor completely. Well, some of the things I like to do with these is to eliminate some really stupid answers. Like, for example, this one has a GCF right here of 2. It can't be the answer. This one has a GCF of X. This one has a GCF of X. Can't be the answer. This one does not have a GCF. This one does not have a GCF. This one does not. This one. So I'm already down to a 50-50 guess. I'm going to show you some cool stuff as we go through. One of the things about their calculator is really nice. All right, so you'll see in a second. Let's see. The GCF, clearly I can take out a 2. And in fact, here it is right here. They're going to tell you what the GCF is. It's 2x squared. I'm going to take a 2x squared out. And I'm going to be left with 6x squared plus 5x minus 6. Well, there's no equals, no. And then I have to factor it. I will forewarn you, I will not factor by any other method than guess and check. I don't believe in any other method than guess and check. If you are using tricks and all these 47 steps, I got something for you in just a second. I'm going to factor this, and then I'm going to show you how to use the other calculator. Once you see this thing on the other calculator, you may want to go out and purchase it. Well, look here. 2 and 3. They helped us. It's going to be 2x and 3x. This is 6. It's going to be 2 and 3. One has to be positive, one has to be negative. Now, if you look at it, you'll notice that the 3 is always with the 2. The 2 cannot be placed with the 2 in this parentheses because it would have a GCF. So the 3 has to go there and the 2 has to go here. And our only job is to figure out which one is going to give us positive 5x. And clearly, if I have these together, that's 9. And these multiply together to give me 4. 9, positive 9 minus 4 is what we want. I'm not going to show you on this one. I'll show you on one problem later. There it is. Choice positive 3. Choice 4. Checking down. There it is. Perfect. Oh, the solutions of this equation are, oh my goodness gracious me. Alright, so I'm going to guess this is not the right answer because notice how these all have radical 5s in them. Not going to be the right answer. And then we're going to eliminate another choice in just a second. Oops, what am I doing? Let me get rid of that. Just get rid of it like this. So I got y squared minus 3y minus 9 equals 0. So if you remember correctly, the quadratic formula, because clearly based on these answers, I'm using the quadratic formula. If you remember correctly, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now some teachers like to put 2a here and 2a here, or put the whole thing over 2a. It doesn't matter. Clearly all the denominators are 2a. That has nothing to do with it. Now, negative b, if I look right here, let me just grab a different color. If I grab right here, see, notice negative b, this is already negative, so negative b would be positive 3. So it can't be this answer. Now I got a little bit of work to do. I got to decide if my discriminant is going to be negative. I'm going to choose that one. If my discriminant is going to be positive, I'm going to choose this one, because notice they're exactly the same thing. Now, this part right here is called the discriminant. If you don't know that, your teacher probably didn't teach it to you, or you forgot. Either way, it doesn't matter. It's b squared minus 4ac. And I'm going to show you how to get that 3 squared to 5 there. So, b squared, negative 3 squared. Never, ever write negative 3 squared here. Using your calculator probably, most of them will tell you that's negative 9. Try it. See. It'll tell you that's negative 9. You can't square something and make it negative. That's just ridiculous. So I always tell my kids, just tell me what it is. What is negative 3 squared? It's positive 9. It's always positive. Minus 4 times a, which is 1, times c, which is negative 9. Well, this really, if I type this in my calculator, I'm not going to do that because I think you guys can handle that. You type this in your calculator, you get positive 45. So, since it's positive, that means it's a positive number under the radical. It can't be imaginary. So the answer is choice 4. Now, just so you know how to simplify the square root of 45, just a little more practice, that's the square root of 9 times the square root of 5, and the square root of 9 is 3. So there's your 3 square roots of 5. Choice 4, kids. Moving on, next page. Let me see if I can adjust this one now. Only going to 14 in this video. Oh my God. How many of you guys look at this problem and go, oh my God, I hate logarithms. They're awful. Don't do that. A couple rules about logarithms as we go through these videos you'll remind yourself is whenever you've got multiple logarithms like this that have subtraction and you want to convert this back to one logarithm, that logarithm was division. When you have division working with logarithms, it turns into subtraction, or subtraction turns into division when you're going backwards, or when you're trying to solve these or simplify these. When you have addition, that's multiplication. Any number in front, like this one right here, or this one right here, become exponents, or were originally exponents. So those would go right here. So really what I have here is the log of x squared. Well, how many answers have x squared? X squared, x squared. This doesn't have an x squared. This doesn't have an x squared. This is going to be the log of y cubed. Y cubed, y cubed. Got those. Now, let me erase a little bit. Try to erase. Let me get rid of all this mess that I have on here. I got rid of those two answers because they don't have a x squared or a y cubed or one of the others. Alright, so this thing will be the numerator. Only this thing will be the numerator. And all of this will be the denominator because that's all the stuff that's being subtracted. So I'm going to log base 10. You don't have to put the 10 of. Now, Log of x squared goes in the top. That's the x squared. Now these two things are being added. When I convert back to one logarithm, they're going to be multiplied. And don't forget, that's a y cubed times a z. And that's the one I'm looking for, and that's choice 1. Yay! Whoa, 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 whoa. We just talked about this. Yo, I'm like prophetic. All right, kids. Negative exponents have nothing to do with being negative. Little coffee. What they do is take it and make it into a fraction. So it will be 1 over x squared minus 1. Oh, that was a great one. To the positive 2/3. Now, that's not one of your choices. That's terrible. So, let's talk about fractional exponents. First of all, we know this is not a choice. We know this is not a choice. You're down to a 50-50 guess. This is how you make your life easy. You remember certain things, and sometimes when your brain's cramping and farting and you don't know what's going on, at least you got a 50-50 guess. Now, take one. If you don't know what to do, take one. Take one right now. Pause the video. Take a guess. See what you say. What do you think? Is it 3? Is it 2? Is it 4? 2 or 4? Don't pick 3. We already eliminated 3. Oh, you're back from the pause. Okay, good. So, fractional exponents. So let me just go back to a basic fractional exponent. Doesn't matter what this is. Let's say x to the 2/3. The denominator, that's the bottom number, the denominator. This is a root. This is a power. I tried to tell my kids. Some of them remember, some of them don't. Roots, they're in the ground. Power up. Roots are in the ground. Power up. So the root is in the bottom, the power is in the numerator. So what do I mean by that? Well, that means since this is a root, this is a cube root of x. But x also has an exponent of 2 squared. So I'm looking for something with a cube root squared, and that would be choice 2. It's the cube root squared. Ooh, man, I'm learning some. Oh my gosh. They are just loving, whoever wrote this test is just loving radicals this season. It's like, whoa, gotta love these radicals. -3, fine. And then square root of 3 plus 5. Which equation is equivalent? I'm going to show you 2 ways to solve this problem. I'm going to show you the way to solve it, and I'm actually going to check my answer, but that check will be a second solution. What you need to multiply by is 1. 1? Okay, I don't mean like this 1, because that would be stupid. Because multiplying by 1 doesn't change the value, does it? So we're going to multiply by a fun one, not a boring one. And some of you are sitting there going, oh yeah, man, that's a lot of fun, Krause. Really loving that. I don't think so, buddy. I don't know who you are. I'm watching this video in like Albany or in like some strange city that Mr. Krause never heard of, like in New York City, that has taken Algebra 2 Regents exam, and this, never mind. I'm probably going to offend somebody, but you're in some small town and you're like, whoa, I don't know, what's going on in that freaking Hilton? I'm from Hilton, by the way, just in case you're wondering. And, yeah, well, alright guys, clearly I just went through a complete rant of about 30 seconds and I have no idea what I was talking about, so I'm going to get myself some coffee. I don't even smoke. One of the things that I've seen a bunch on these Regents exams is talking about conjugates. You see this word conjugate? Yes, that's my spell. That's my amazing penmanship. Conjugates. Conjugates are the exact same set of parentheses, but with a plus sign, or in this case with a different sign. This is a minus. This will be a plus. So we are going to multiply by 1, but we're going to multiply by this 1. The same thing over the same thing as 1. By doing that, we'll be able to simplify this and get to the right answer. Now, so the numerator, all right, let's double distribute the numerator. So this is x square root of 3 times the square root of 3 is 3. The square root of 3 times 5 is plus 5 square roots of 3. And then this is going to be plus 5 square roots of 3. And then plus 25. Well, these two make 28 plus 10 square roots of 3. Do I have anything like that? Nope. But what I do have, and I'm actually done with the problem, well, I might be done with the problem, but what I do have is multiples, or half. See the 5s? Half. So I know these two aren't going to be the right answer. All right, let's do the bottom anyway. I need some more space. All right, back to writing. Let's try blue. So let's multiply these two together. That's radical 3. Now in the future, I'm not going to do this, but I'll show you today. Plus 5 square roots of 3, minus 5 square roots of 3. Those always cancel because I don't want any radicals in the denominator. And then negative 5 times positive 5 is negative 25. And so that gives me negative 22 in the denominator. Ah, I thought I was right, but I was wrong. So if you notice, I can take a 2 out of all of these. 2 makes this 14, a 2 makes this 5, and a 2 makes this negative 11. Well, I can't have a negative in the denominator, so we'll pop that up to the top, that negative up to the top. So it's negative 14 minus 5. Oh, see how they put the negative? They just put the negative out front. See how they put the negative out front? The negative goes to the whole thing, and there's your answer, number 1. I haven't been checking my notes to see if I make any mistakes. I don't think I've made any mistakes. Let me see. Looks like we're good so far. One last one. Which one is not a function? Okay. So here's a question on whether or not you can quickly recognize what the graph of something looks like. For example, this one should be pretty easy. That's just a line. This one should be pretty easy. This is just a parabola because it has just a single x squared with a y. I don't know why I drew it like that, because when I bring this x squared over its negative, this actually turns out to be a upside down parabola. This one, not so easy. So let's take a look and see what this looks like. Maybe you don't even know what these things look like. I'm going to solve for y and graph this thing. Oops. Control T. And let's see if I can get a new... Is that how you do a new graph? I don't know how to get a new graph. Anyway, I'm just going to change this. I'm just going to delete this. And what was it? 4 over x, wasn't it? 4 divided by x. Well, that looks like a function. So that one is just that classic. Or maybe it's up in here and here. It doesn't matter. It's one of those ones. But, oh, I need to show you something. So in order for it to be a function, you have to remember that, oh, I forgot to tell you this. You guys are probably like, what the, how am I supposed to know? It has to pass the vertical line test. Passes the vertical line test. Passes the vertical line test. Passes the vertical line test. In this case, I think it was here and here, right? Passes the vertical line test. No matter where you draw a vertical line. It's this one that's the answer, and that's because this has an x squared, or squared, and a y squared. And anytime you have an x squared and a y squared, with at least algebra 2 trig, it's going to be a circle. At some point, it might be an ellipse or an hyperbole, but it doesn't matter. It will always be something like this, and this fails the vertical line test, therefore it is not a function. All right, this is going to be the last problem of this one. And, of course, we're going to end on a really difficult problem. So, let's see if we can figure out what A actually is. Let's see if we can figure out what A actually is. I'm going to show you a couple different ways to do this problem. This one's kind of those tricky questions, but I think that you all know that the tangent inverse, or the inverse tan of 2/3 would be equal to A, correct? So if I come over to my calculator and I go, okay, calculator, let's go to the calculator, and we do inverse tan of 2 divided by 3, I get 33.69. And then my answers were, my first one was the cotangent of A. So let me just try the cotangent of that. I think clearly, I think most of you realize that's not going to be the answer. Cotangent of that, 1.5. That is not 2 over 3, that's 3 over 2. That's not going to be it. Ooh, that's a good choice, though. All right, that's not it. So then we'll do the, well, the first two were cotangent. If you look back, the first two were cotangent, or if you're looking at your sheet, the first two were cotangent of this angle is equal to 2/3. This is not 2/3. Or 1/3, and this is not 1/3. So that's not it. And so then let's try the next one. The next one says we'll do the cotangent of 90 minus this. So 90 minus this. And 0.66666666666. Wow. I don't know why this is coming up as not fractions. I'm going to go 0.66666 is 2/3. So I don't know why my settings are not. They should have been come up as fractions. Anyway, let's go to cancel. All right. So anyway, that's the answer. Choice 3. The other thing that you got to remember is that when you have cofunctions, like tangent of some angle and cotangent of some angle, these two angles have to, if they add to 90 degrees, then they're equal. So if this is A and this is 90, this would be cotangent. 90 minus A. If I take A and I add 90 minus A, these cancel, they add to 90, which means that they will, in fact, be equal to each other. And that's why it is choice 3. And that's the end of June 2010, part 1 through 14. Hope you guys enjoyed it. If you want to check out the next one, just hit the next video. It should be coming up soon. Or you can go look for it. Hopefully you find it. If you like what you see, please hit subscribe. Like I said, I'm trying to get to 500 subscribers. I think I'm allowed to do a couple different things on YouTube that might be useful to all of us once I get there. All right. Take care. Peace out.